Yes, Assalamu alaikum and good morning. Um, just wanted to make sure if you are able to see the screen. Great. So I have the chat window open and I am actually not in my office, traveling in a remote location. So I'm not sure how the internet service will work here. Hopefully should be fine. But if you feel that the internet service is deteriorating, then please just let me know in the chat window, and I will be happy to repeat what we have just discussed. Okay, so we have finished the business of talking about discrete and continuous random variables and about multiple random variables as well. We talked about correlations, covariance, etc. So this is sort of a transitioning to the second part of the course, and the first topic that we are going to cover is a transitional topic. It's not a main topic, but it's a transitional topic, yet an important one. And this is about the estimates of probability. Estimates of probability. So many times you don't know the distribution of a random variable. If you know the distribution of a random variable, the PDF, the PMF, the CDF, if you or the even the moment generating function, you know everything about the random variable. But often it will happen that you will not know the distribution of the random variable. You can estimate it by making some measurements, performing the experiment and figuring out what values the random variable is taking, but you don't have access to the distribution of the random variable. So can you say something about a random variable X if you don't know anything about it? So can you say something about X? Can you say something about a random variable X if you know nothing about it? So for example, can you answer this kind of a probability question? Probability X is greater than or equal to 72. Can you answer this question without knowing anything about X? Answers in the chat window. कोई इसका कुछ आंसर दे सकते हैं? Yeah. So but this is just as random question as anything. You can't say, and without knowing about the random variable, you don't even know what is the range of the values that the random variable can take. So you can't tell anything about X. The next question is, what if you know about the mean? So now can you make any guesses? Now can you make any guesses about the random variable? Yes or no? कोई अगर आपसे probability question पूछे, probability X is greater than 3, can you answer this? Maybe. Can you answer this? Maybe. Well, when you say maybe, that means I'm not precisely going to be able to answer it, but I can maybe answer it in a probabilistic way. So think about it. Okay, every week we have a quiz in the class, and there are 30 points for every quiz. So think about a specific quiz. If I tell you that the average on the quiz, is 10, the class average on the quiz is 10, then I am guaranteed that it is not possible that half of the class would have scored more than 20 marks. So it would not be possible for half of the class to score more than 20 marks. क्योंकि अगर आधी क्लास के 20 marks से ज़्यादा होंगे, तो automatically mean आपके पास 10 से ऊपर निकल जाएगा. So if I tell you that the mean of the class is 10, then no more than 50% of the class can have more than 20 points in the quiz. Okay, so if you choose a random student, the probability that that student would have more than 20 marks, you should be able to limit that probability. You should be able to limit that probability. क्योंकि 50% से ज़्यादा class के नहीं हो सकते. So that means that probability has to be less than 50%, less than 50% or less than 0.5. So if you know about the mean of the random variable, maybe you can tell roughly something about the random variable. So, and what if you also know the variance in addition to the mean? Well, if you know the variance, then that would you can tell probably something even more about the random variable, Okay. सो जैन खान वो मीडियन होगा, लेकिन यहाँ पे मीडियन का जिक्र नहीं हो रहा, ठीक है. इट जस्ट टर्न्ड आउट के वो 10 और 20 का मैंने फिगर यूज कर लिया. सो इफ आई टेल यू कि क्लास का एवरेज जो है वो 10 से ज्यादा नहीं है, और मैं पूछूं कि क्या प्रोबेबिलिटी है कि एक रैंडमली चोजन स्टूडेंट के 25 से ज्यादा मार्क्स होंगे. नाउ आई एम नॉट टॉकिंग अबाउट 20, आई एम टॉकिंग अबाउट 25 से ज्यादा. तो 25 से ज्यादा मार्क्स होने के लिए ये 50% से भी कम नंबर होगा. उससे ज्यादा लोगों के उससे ज्यादा नंबर नहीं हो सकते, ठीक है. We'll give you an example. So in order to tell you something about the random variable, when you just know the mean value of the random variable, I'm going to talk about what we call Markov inequality. And these inequalities that we are going to study, they give you an estimate of the probability. If you know the PDF, PMF, you know exactly what the probability is. But if you don't know the entire PDF, you can only make an estimate. Okay? And the Markov inequality is pretty simple. Okay? For if x is greater than or equal to 0, which means que non-negative random variable, and the Markov inequality says that the probability x is greater than or equal to a, where a is some constant, is always going to be expected value of x less than expected value of x divided by a, where a is greater than 0, of course. Okay. And the proof is very, very simple. There are two ways this can be proved, and both of those ways are shown in the notes that we will upload. But I'm just going to show you one single proof, which is also very simple. So expected value of x, we know, is from 0 to infinity by definition fx x dx. I can break this integral down from 0 to a into f x dx plus a से infinity. कुछ भी नहीं किया, इंटीग्रल को दो पोर्शंस में ब्रेक कर दिया, fx x dx. Now if you look at this first integral, you can always write this to be equal to, greater than equal to. अब ये मेरे पास दो चीजें हैं. I know that expected value of x is the sum of these two guys, If I drop one of these two guys, I consider only one of these things on the right. Okay. If I consider only one of these things on the right, then I can put this greater than equal to sign. So मैं इसमें ये करता हूँ कि I'm going to only choose this x fx x dx. इसको मैंने ड्रॉप कर दिया, ये वाली जो टर्म है इसको ड्रॉप कर दिया. So obviously if something is equal to the sum of two quantities, तो वो दोनों से जो है ना वो दोनों quantities से बड़ा होगा if both of those are positive, which is the case here. Okay. Now, if you look at this, this guy here, from a to infinity, see in this integral, x is always greater than a. X is always greater than a. So I can write this as x is always greater than a. So this guy has to be greater than or equal to a to infinity. x की जगह पे मैंने a लिख दिया. क्यों? इसलिए कि इस इंटीग्रल के अंदर x goes from a to infinity. x is always greater than a. तो मैंने x जो बड़ी बड़ी वैल्यूज ले रहा था, a से छोटा कभी नहीं होता था, x की जगह पे मैंने a लिख दिया. तो इसका मतलब है कि मैंने अब और छोटा कर दिया उसको, इससे बड़ा नहीं हो सकता, ठीक है। सो दिस गाय हियर इज सिंपली a बाहर आ जाएगा इंटीग्रल से, एंड दिस इज प्रोबेबिलिटी x इज ग्रेटर देन a, एंड दिस इज expected value of x greater than equal to a times probability x is greater than a, which completes the proof. यही तो Markov inequality थी कि x is greater than a is less than equal to expected value of x divided by a. Okay. There is an alternate proof which is given in the notes. So I'm going to give you this example. Class average on a quiz is 10 out of 30. 10 out of 30. So pick a random student. Probability their score is greater than 25. So probability x is the score of the random student. The probability that x takes a value greater than or equal to 25 is always going to be less than or equal to the average value of x, which is given, which is 10 divided by 25. So this is equal to 0.4. So no more than 40% of the class can score more than 25. It says no more than 40% of students can obtain more than 25 marks. Okay. Couple of more examples. 2 examples आपको और देते हैं. Okay. So let's say on average, 40% trains are late. 40% trains are late each hour. हर घंटे में. Each hour. It doesn't matter if you consider hour or day or week, but 40% of the trains are late each hour. Okay. The question is, bound the probability that 60% or more will be late in a given hour. एक randomly selected hour है, हमने ये probability बतानी है. So in this case, I'm going to define x as the proportion of late trains. And I'm being asked what is the probability that a randomly selected train is late. Okay, is late. X is greater than 0.6. More than 60% of the trains are late. So this is going to be less than equal to the expected value of x, which is 40%, okay, less than equal to 0.4 over 0.6. So this would be equal to 2 over 3. अब देखें, ये आपको probability नहीं बता रहा, ये आपको bound बता रहा है, bound. Okay. This guy is only telling, Markov inequality is only telling you the bound. It is not telling you the exact probability. ये आपको ये बता रहा है कि ये इससे छोटी होगी. कितनी छोटी होगी हमें पता नहीं, हो सकता है ये बहुत छोटी हो इससे, लेकिन at least it is guaranteed that इससे छोटी होगी. एक और एग्जांपल आपसे करते हैं. एग्जांपल, ये ट्रेन वाली एग्जांपल कंसीडर करते हैं. सो लेट्स से एवरेज डिले on a train, yeah, average train delay on any randomly chosen train, is 40 minutes. ये ट्रेन जो है ये randomly chosen है. Okay. So bound the probability. Okay. A random train, is 60 minutes late or more late. या इसको हम कह सकते हैं कि एटलीस्ट 60 मिनट्स लेट है, एटलीस्ट 60 मिनट्स लेट है। सो ऑन एवरेज ट्रेन जो है वो 40 मिनट लेट होती हैं पर ट्रेन, ऑन एवरेज। कोई ट्रेन टाइम पे चली जाती है, कोई 2 घंटे लेट हो जाती है, बट ऑन एवरेज दे आर 40 मिनट्स लेट। आई एम इंटरेस्टेड इन के एक ट्रेन को आपने रैंडमली चूज किया एंड दैट ट्रेन इज 60 मिनट्स लेट। सो हियर आई डिफाइन x to be equal to minutes by which a randomly chosen train is late. Okay, so I'm basically asked the question, what is the probability x is greater than or equal to 40? X is greater than or equal to 40. So, and what is the, by Markov inequality, this is less than or equal to, what is the expected value of x? Expected value of x, what we are asked, what is the probability x is greater than or equal to 60? Which is less than or equal to expected value of x. Expected value of x, x is the number of minutes by which a train is late, is 40 divided by 60. Okay, is equal to 2 by 3. ये देखें वही आंसर आ गया, मैंने डेटा ये सब हमने पिक किया था, वही आंसर आ गया, बट you know, some different ways of posing the questions, two different questions in a similar situation. Okay, so now the question is कि ये Markov inequality आपको exact probability नहीं दे रही, but it is only giving you the bound. How good is that bound? How good is the bound provided by Markov inequality? So bound जो होते हैं वो loose भी होते हैं. So for example, if I say कि the probability of some event happening is less than 1, I'm not giving you any information, क्योंकि सबको पता है कि वो less than equal to 1 ही होती है. If I tell you कि the probability of something is happening is less than equal to 0.1, so then that is some information. That is some information. कि अब हमें पता है कि the event cannot happen with more than 10% probability. But अगर ये बताएं कि the probability of something happening is less than equal to 1, this is useless information. This bound is very, very loose, very, very loose. I need a sharp bound, a crisp bound, a more tighter bound. Okay, so let's try to figure out how good is the Markov inequality. For this, let's consider an example. Okay, एक example consider करते हैं कि x is uniform between 0 and 4. Okay, let's say we know this distribution, but we don't know this distribution. एक हमने example pick किया जिसमें x is between uniform and 0 and 4 है. We know that in this case expected value of x is 2. We also know the variance of x. Actually, knowing this, I can tell you the exact answer about x. Okay, I can tell you the exact answer about x. Okay. So I'm interested in finding out what is the probability x is greater than or equal to 2. You know, you can give the exact answer. And the reason that you can give the exact answer is because you know the distribution. Okay? And what would be the exact answer? Answer is in the chat window. What is the probability x is greater than or equal to 2? X is uniform between 0 and 4. What is the probability x is greater than or equal to 2? Answer is in the chat window. Is 1 over 2. Is 1 over 2. It's 0.5. Okay. Now, for a moment, assume that you don't know the distribution. Assume that this distribution is not known to you. Although ठीक है, random variable की distribution की होगी कोई, but it is not known to you. But you do know about the expected value. वैसे तो expected value आप experimentally roughly find कर सकते हैं, estimate कर सकते हैं. We will tell you how. But let's say you know the expected value of the random variable, but we don't know the distribution. We don't know the distribution. Okay. So let's try to apply the Markov inequality. And the Markov inequality would say that the probability x is greater than or equal to 2 should be less than or equal to. Again, ये bound है. यहाँ पर तो आपको exact answer मिल गया था. यहाँ पे आपको bound मिलेगा. Should be less than or equal to. Of course, इस 0.5 से तो बड़ा ही number आने वाला है. ठीक है? Because 0.5 is the exact probability. Now, the probability x is greater than or equal to 2 is less than or equal to expected value of x, which is 2, divided by 2, which is 1. Very bad information. Very bad information. हमें उसने बता दिया कि probability x is greater than equal to 2 will be less than equal to 1. वो तो हमें पता है, वैसे ही होनी है, ठीक है, हमें ये नजर भी आ रही है कि 0.5 होती है, एग्जैक्ट भी पता है हमें. बट if we don't know the distribution, if we only know the mean, then the Markov inequality cannot tell you more than this. Another example here could be probability x is greater than or equal to, let's say, x greater than or equal to 3. X greater than or equal to 3. What is the exact answer? Answers in the chat window. Answers in the chat window. What is the exact answer? Probability x is greater than or equal to 3 is uniform between 0 and 4. So 0 से 4 तक uniform distribution है. 0 से 4 तक uniform distribution है. 0 से 4 तक uniform distribution है. So 2 is here, 3 is here. I am asking you, what is the probability x is greater than 3, which means this region. And this region is a quarter of the total density, which is equal to 0.25. Okay. And what does the Markov inequality tell us? Markov inequality tells us that the probability x is greater than 3 is going to be less than or equal to the expected value of x, which is 2 divided by this 3 guy here, 2 by 3. Okay. Which is true, which is always true. Markov inequality is something which gives you the true information. This is the information you can bet your life on. Okay. However, this information is still just a bound, and you can see that 2 over 3 is much larger than 0.25. If somebody tells you that the probability x is greater than or equal to 3 is less than 0.3, is less than 0.3, that's a sharper bound. This is a loose bound. This is a loose bound. This bound is a loose bound. Okay. Now the question is, can the bound be sharp or tighter if we know a bit more about x? Well, uski variance agar pata ho. Okay. Can the bound be sharper if we know more about x? So obviously लग रहा है कि कोई additional information होने से कोई नुकसान तो नहीं होगा, इतना तो हम बता ही सकते हैं. तो maybe we can tell a little bit more if we know more about x. Say its variance. Say its variance. अगर उसकी variance भी आपको पता चल जाए तो, ठीक है. If you know the mean and the variance of a random variable, then we have another inequality, which is called Chebyshev inequality. Chebyshev inequality. And the Chebyshev inequality, it tells you how far a random variable is from the mean. वो mean से कितनी दूर हो सकता है, क्या tendency है उसकी. Okay. Markov inequality तो आपको बताती है कि what is the probability x takes a value greater than some threshold. X takes a value greater than some threshold. यहाँ पे ये बताती है कि वो अपने मीन से कितना दूर भागता है. And that answer is given in terms of variance. अगर आपको variance का पता हो, and we know कि variance हमें ये भी बताती है is the tendency of a random variable to move away from the mean. Smaller variance का मतलब है कि random variable की जो values हैं वो mean के आसपास होती है. Larger variance का मतलब है कि random variable की values दूर होती हैं. Okay. So there is a question, Junaid ने question पूछा, in Markov inequality, is there any limitation on A? The limitation on A is what we have written here, A greater than or equal to 0. Greater than or equal to 0. You can have A greater than or equal to expected value of x. Of course, हमने ये पूछा यहाँ पे सवाल कि probability x is greater than or equal to 3, इसमें expected value of x जो है वो 2 है, तो we can answer this question, x is greater than or equal to 3. So Markov inequality will give you a very loose bound if A is smaller than x, if A is smaller than expected value of x. If A is smaller than expected value of x, it will give you a very loose bound. ये हमें मिला यहाँ पे loose bound. ये हमें बता रहे हैं कि probability x is greater than or equal to 2 is less than or equal to 1. Big deal. We already know that. अगर मैं आपसे पूछता what is the probability x is greater than or equal to 1, वो आंसर आपके पास होता है 2 डिवाइडेड बाय 1 लेस देन इक्वल टू 2। ऑफ कोर्स कोई प्रोबेबिलिटी 1 से बड़ी नहीं हो सकती, और ये इनइक्वालिटी हमें बता रही है कि लेस देन इक्वल टू 2 होगी, ठीक है। दिस इंफॉर्मेशन वुड बी यूजलेस फॉर अस, वेरी लूज बाउंड, very loose bound. So coming back to Chebyshev inequality, Chebyshev inequality tells you how far a random variable is away from the mean, and for that the variance is taken into account. So in this case, mean and variance are known, both are known, mean and variance are known, and the inequality says the difference between x and mu in either direction, x can be greater than mu, x can be smaller than mu. So that's why we have taken this modulus here, x minus mu, the magnitude of the difference x minus mu exceeds a number a is always less than equal to sigma square over a square, sigma square over a square. इसकी alternate form जो इस्तेमाल होती है वो भी इस्तेमाल होती है, x minus mu greater than equal to a times sigma is less than equal to 1 over a square. ये दोनों इस्तेमाल कर सकते हैं, एक ही equivalent चीज है, equivalent. And the proof is very, very simple. Okay, so we know that x minus mu whole square is always greater than 0, is always non-negative. अगर ये non-negative है तो इसके ऊपर मार्कोव इनइक्वालिटी भी लगेगी, बिकॉज मार्कोव इनइक्वालिटी अप्लाइज टू एनी नॉन नेगेटिव रैंडम वेरिएबल। ओके, सो इसके ऊपर मार्कोव इनइक्वालिटी लगेगी, लगा के देखते हैं। सो द प्रोबेबिलिटी दिस रैंडम वेरिएबल, if x is a random variable, then x minus mu whole square, which is a function of a random variable, is also a random variable. This random variable exceeds a value a square, ठीक है, exceeds a constant a square. ये constant अब मैंने a के बजाय a square ले लिया है, and for a reason. Markov inequality tells us that this has to be less than equal to the expected value of the random variable, which is expected value of x minus mu whole square divided by a square. Markov inequality यही कहती है कि अगर कोई random variable हो, the probability that the random variable takes a value greater than a constant is less than equal to the expected value of the random variable divided by that constant. Okay, and now on the left hand side, what you have in the probability expression, x minus mu whole square is greater than equal to a square. This is the same as saying कि x और mu के दरमियान जो difference है वो a से exceed कर जाता है. These two things are equivalent. ये दोनों equivalent हैं, ठीक है, and this is less than equal to what is the expected value of x minus mu square. This is the definition of variance, which is sigma square over a square. So proved. एक ही step में prove हो गया. Abdullah Bashir, you have a question? Please go ahead and ask.
Sir, I had a question which you answered about the Markov inequality, that if a is if a is lesser than the expected value,
जी जो हमारे आंसर कर दिया जी
yes
जी great, thank you. Okay, now some examples. So let's consider this example. X is uniform between 1 and 5. Okay, let's say this, हमें ये अगर हमें पता हो तो हम एग्जैक्ट आंसर कर सकते हैं प्रोबेबिलिटी के, ठीक है। लेट्स अज्यूम कि x हैज दिस डिस्ट्रीब्यूशन बट दिस विल बी नॉट नोन टू यू, ये आपको पता नहीं होगी इसके बारे में. व्हाट इज एक्सपेक्टेड वैल्यू ऑफ x? आंसर इन द चैट विंडो वेरी क्विकली. एंड द वेरिएंस ऑफ x, आंसर्स इन द चैट विंडो. The expected value of x is 3, variance of x is b minus a whole square over 12, which is 5 minus 1, 4 whole square over 12, 16 over 12, or 4 over 3. Okay. So सबसे पहले तो आपसे पूछते हैं what exact मुझे आंसर करें. What is the probability x is greater than equal to 4? Answers in the chat window. Exact answers. I need the exact answer. Exact from distribution. वो जो ऊपर दी हुई है हमें पता है कि वो distribution है. So this answer would be, answers in the chat window, is 0.25. The second question is, now assume that the distribution है तो यही distribution, लेकिन आपको नहीं पता, आपको उसका expected value पता है सिर्फ. You only know the expected value. Then you cannot apply the Chebyshev inequality because you don't know the variance. You can only apply the Markov inequality, and the Markov inequality says that the probability x is greater than 4 is going to be less than equal to the expected value, which is 3 divided by 4, which is equal to 0.75. Okay, this is Markov. Okay, this is Markov inequality, and this assumes that only mean is known, is told. जिससे सवाल पूछ रहे हैं उसको सिर्फ मीन बताया है और इससे ज्यादा कुछ नहीं बताया. Now the next question I'm going to ask is, of you probably can guess, कि इस केस के अंदर हम क्या Chebyshev लगा सकते हैं. And the Chebyshev inequality, if you take a look at it, it only tells you कि how far x moves away from the mean, how far a random variable moves away from the mean. ये कितनी दूर चला जाता है ये देखेंगे, बताता है. ये इस तरह का आंसर नहीं करता प्रोबेबिलिटी x ग्रेटर देन 3 है, x ग्रेटर देन 4, इसकी प्रोबेबिलिटी क्या है, ये नहीं. ये आपको ये बताता है कि x अपने मीन से कितना दूर जा सकता है. The difference between x and the mean exceeds a certain number, उसका आंसर करेगा ये. ठीक है. So in general हम इसमें Chebyshev लगा नहीं सकते, but if we know the distribution, can we apply Chebyshev? So not in general, but we may, if we know that the distribution is symmetric, जो इस केस में है यूनिफॉर्म सिमेट्रिक होती है. आपको डिस्ट्रीब्यूशन का नहीं पता, लेकिन ये किसी तरह से पता चल गया कि डिस्ट्रीब्यूशन जो है वो सिमेट्रिक अराउंड द मीन है, सिमेट्रिक अराउंड द मीन. तो यूनिफॉर्म की डिस्ट्रीब्यूशन इज सिमेट्रिक अराउंड द मीन. सो आई कैन ट्राई टू आंसर दिस क्वेश्चन, प्रोबेबिलिटी x ग्रेटर देन 4, ये वाला आंसर हमने करना है. जो हमें एग्जैक्ट का पता है कि 0.25 होती है, और मार्कोव ने हमें बताया कि लेस देन इक्वल टू 0.75 है. इट्स अ लूज बाउंड. सो आई एम जस्ट trying to figure out if the Chebyshev inequality gives you a bound which is tighter than 0.75. Can we give an answer to that? So इसको हम ऐसे लिख सकते हैं कि the probability x minus 3, if 3 is the mean here, what is the probability x minus 3 exceeds 1? ये मैंने 1 एक खास रीजन पे लिखा है, इसलिए लिखा है कि ये 3 और 1 ये दोनों मिलके आपके पास ये 4 बनाते हैं. 3 और 1 मिलके 4 बनाते हैं. सो यू विल सी कि इसको मैं मैनिपुलेट करूंगा और I will be able to answer this question, what is the probability x is greater than or equal to 4. Okay, so we know that this is less than or equal to 4 by 3, which is the variance divided by 1. Okay, ये कोई अच्छा आंसर नहीं आया. ये आपको बता रही है कि एक इवेंट है, उस इवेंट की प्रोबेबिलिटी लेस देन इक्वल टू 4 by 3 है, which is greater than 1. भाई हमें पता है कोई भी इवेंट है उसकी प्रोबेबिलिटी 1 से बड़ी नहीं हो सकती. किसी भी इवेंट की प्रोबेबिलिटी 1 से बड़ी नहीं हो सकती. बट जस्ट फॉर द सेक ऑफ यूजिंग द Chebyshev inequality, ठीक है, हम ये मान लेते हैं. सो नाउ द इक्वेशन ऑन द लेफ्ट हैंड साइड टेल्स यू कि प्रोबेबिलिटी के दिस इवेंट हैपेंस, दिस इवेंट टेल्स यू कि x और 3 के दरमियान जो डिफरेंस है which exceeds 1. So here is 3. So x, this is 4 and this is 2. So this is the probability कि x minus 3 exceeds 1. ये इस रीजन की और इस रीजन की बात हो रही है. This region, the red one, the red region that I'm showing, in this region x minus 3 का difference, x और 3 का difference in either direction is less than 1. So we are talking about this blue region here, and I'm saying this probability is less than equal to 4 by 3. We know it would be less than 1, ठीक है, but let's say कि हम ये 4 by 3 के साथ चलते हैं, ठीक है. So that means कि the probability that x minus 3 is greater than 1. तो मैं अब एक साइड कंसिडर कर रहा हूँ when x is greater than 3. So ये probability कितनी होगी? x minus ये वाली probability, this blue probability, x minus 3 is greater than 1. ये if the distribution is symmetric, so this probability will be equal to this probability. will be less than or equal to 4 by 3 divided by 2, which is equal to 2 by 3. So the probability x is greater than 4 is less than or equal to 2 by 3, which is slightly better than this. 0.67 hota hai. So this is slightly better than this, slightly tighter. But we do know कि in fact हम इससे better भी कर सकते थे क्योंकि हमें पता था कि probability could have done better. Could have done better. How? We know that the probability x minus 3 exceeds 1. ये जब 4 और 3 लिखा है तो हमें पता है हम इसको 1 से बड़ा तो कभी नहीं करेंगे. वर्स्ट केस में जो है ना वो 1 हो जाएगी. वर्स्ट केस में 1 हो जाएगी. So the probability x minus 3 exceeds 1 if it is symmetric. If it is symmetric, this will be less than or equal to 1 over 2. अगर ये symmetric है, so we are talking about x minus 3 exceeding 1. So this is 3 and this is 4 and this is 2, and we are talking about not this region, but we are talking about this blue region here. So blue or red region ये वो हैं जहाँ पे x minus 3 का magnitude, the magnitude of x minus 3 exceeds 1. So and the blue region is the one जहाँ पे x minus 3 is greater than 1. Of course, red is the region when 3 minus x is greater than 1. Okay. So this blue area and red area are going to be equal. Why? Because the distribution is symmetric. The distribution is symmetric, we get this answer, which is 0.5, which is even tighter than 0.67, even tighter than 0.67, obviously. Okay. So there is another twist to the Chebyshev inequality. It's called the one-sided Chebyshev. When we don't know that the distribution of the random variable is symmetric. Okay. So when we don't know that the distribution is symmetric, तो फिर हम कब कैसे इस तरह के आंसर करेंगे? फिर हम कैसे आंसर करेंगे x minus 3 greater than 1 या x greater than 4, इस टाइप के आंसर कैसे करेंगे? क्योंकि चेबिशेव हमें इस तरह का आंसर नहीं करने देती. चेबिशेव तो हमें ये कहती है कि मैं आपको इस तरह का आंसर करने देंगे कि x और मीन के दरमियान जो डिफरेंस है that exceeds a, इस तरह का आंसर करने देंगे. सो इसलिए हमने we talk about this one-sided Chebyshev inequality, and this gives you the answer to this kind of a question: x minus mu greater than equal to some number a. देखिए मॉडुलस नहीं है इसमें. This is for x greater than mu. This is for x greater than mu, and it can be proven. I will not prove it here that it's less than sigma square or sigma square over a square for x is greater than mu. X smaller than mu के लिए भी यही expression. So the probability mu minus x exceeds a is less than equal to sigma square over sigma square plus a square. दोनों cases में यही चलेगी. For x is less than mu. दोनों cases में एक ही होगी. Okay. So example करते हैं. Previous case हमारे पास था x uniform between 1 and 5. Expected value हमारे पास थी 3. And the variance of x was 4 over 3. 4 over 3. So the probability that x minus 3 is greater than 1 using the one-sided Chebyshev, हमें अब पता नहीं है कि डिस्ट्रीब्यूशन यूनिफॉर्म है. हमें ये भी नहीं पता कि डिस्ट्रीब्यूशन यूनिफॉर्म है. ये भी नहीं पता कि सिमेट्रिक. If we don't know that the distribution is symmetric, then we can't apply the general Chebyshev inequality. We have to apply the one-sided Chebyshev inequality. It says that this has to be less than or equal to sigma square, which is 4 over 3, divided by sigma square plus a squared, which is 1 squared is 1. So this is equal to 4 over 7. Okay. So the probability that इसको अगर चेंज करें थोड़ा सा, x greater than equal to 4 is going to be less than equal to 4 over 7, which is equal to 0.57. Okay. So ये थोड़ा सा लूज है as compared to 0.5. थोड़ा सा लूज है as compared to 0.5, but still reasonable. I'm going to give you another example. Same uniform के case में. And that example is X is uniform between 1 and 5. We know that expected value of X is equal to 3. Variance of X is 4 over 3. Same example. And I am interested in the probability X is greater than or equal to 4.8. This is I am interested in. So true probability kya hoga? True probability answers in the chat window. What is the true probability X is greater than or equal to 4.8? So Usman, आपने सवाल पूछा what if X is equal to mu? So X minus 3 greater than or equal to 0 करेंगे हम. X minus 3 greater than or equal to 0. ठीक है. A को हम 0 ले लेंगे Chebyshev के केस में. One sided Chebyshev के केस में A would be 0. So true probability. Who will answer this question? What is the probability X is greater than or equal to 4.8? X is uniform between 1 and 5. Answers in the chat window, please. What is the true probability? ये कोई तो इसका जवाब दे. Guys, are you guys able to hear me? Yeah, 0.05. So probability X is greater than equal to 4.8 is equal to ये होगा 4.8 और 5 के दरमियान जो डिफरेंस है 5 minus 4.8 divided by 5 minus 1, which is equal to 0.2 over 4, which is equal to 0.05. ठीक है. कैसे? ये आपके पास 1 से लेके 5 तक यूनिफॉर्म है and I'm asking the probability कि ये 4.8 से बड़ा हो. 4.8 से बड़ा होने के लिए ये बस आपने करना है. ठीक है. The next question is what is the bound given by Markov inequality? Markov inequality आपको क्या bound दे रही है? Probability X is greater than or equal to, and now the assumption is that you only know the mean, you don't know the distribution, you don't know the variance. Okay, so probability X is greater than 4.8 is going to be less than or equal to expected value of X, which is 3 divided by 4.8. Then this would be equal to 0.625. तो ये 0.05 हमारे पास करेक्ट प्रोबेबिलिटी है, ट्रू प्रोबेबिलिटी है. 0.625 वेरी लूज बाउंड, कोई टाइट बाउंड नहीं है. दिस इज करेक्ट. लूज बाउंड का ये मतलब नहीं है कि गलत आंसर आ जाए. आंसर ठीक है, बट ये देखिए हम इसको खास फायदा नहीं है इस तरह के आंसर का. What about generic Chebyshev inequality? Generic, not one-sided. Generic Chebyshev inequality. So symmetry is known now. We know it is symmetry. Symmetry is given, is known. Symmetry is known. So the probability I can write X minus 3 is greater than or equal to 1.8. And the reason we wrote 1.8 is 1.8 and 3 together they make 4.8. So this would be less than or equal to sigma square variance, which was 4.3 divided by 1.8 ka square, and this answer is 0.411. So probability that X minus 3 exceeds 1.8, symmetric hai, other side consider ki, this would be less than or equal to 0.411 divided by 2, which is 0.2055. So this is the same as the probability X is greater than or equal to 4.8. 4.8 is going to be less than or equal to 0.2055. So ये भी loose bound है compared to this 0.05, which is the true probability. True probability के मुकाबले में तो ये loose है, but compared to Markov, it's much tighter more. But obviously not compared to the actual guy. Okay. So let's take a look at one-sided Chebyshev. one-sided Chebyshev. One-sided Chebyshev, you don't know whether there is no information about the symmetry. No info about symmetry. No information about the symmetry. If you have no information about the symmetry, then the probability that x minus 3 exceeds 1.8 is going to be less than or equal to sigma square, which is 4/3 divided by sigma square plus a squared, which is 1.8 square. So this turns out to be equal to 2915. Okay. And you can see that this is not better than generic. This is not better than generic. Is not better than the generic Chebyshev. Okay. So one-sided Chebyshev में आपके पास कम information है. आपको पता नहीं है कि symmetry है या नहीं. So generic Chebyshev में, in addition to generic Chebyshev, if you know that the distribution is symmetric, this is more information that you have, so you can come up with a tighter bound. So I'm going to talk about this was the bound on probability, by the way. Bound on probability. There is a bound on expected value. You can come up with that as well, and that is captured by what we call Jensen's inequality. Jensen's inequality, and Jensen's inequality says this is the bound on expected value. But ऊपर हमने देखे bound on the probability, and this is the bound on the expected value. It says that if a function fx is convex function कौन से होते हैं? Convex function वो होते हैं कि जो इस तरह के हो, e to the power x square, जहाँ पे if you consider any chord of the function, कोई से दो point लेके उनको मिला दें, उसको chord बोलते हैं. The chord will always lie above the function. The chord will always lie above the function. So if fx is a convex function like this, if it's a convex function, then expected value of f of x is going to be greater than the f of expected value, the function of the expected value. Okay. और example इसकी क्या है? Example इसकी ये है, expected value of x square. X square is a convex function. X square का हमें पता है कि ग्राफ किस तरह का होता है, इस तरह का होता है. So x square is a convex function. So this would be greater than the function of the expected value, and the function is a square here. So this would be expected value of x whole square. ये उससे बड़ी होगी. और ये हमें पता भी है कि ऐसा होता भी है. क्यों हमें पता है कि ऐसा होता है? कि हमें पता है कि variance of x is equal to expected value of x square minus expected value of x whole square, and this is always greater than or equal to 0. It's always greater than or equal to 0 for any random variable. ठीक है? तो इसलिए this follows from here. Okay? ये तो खैर हमें variance से पता है, but also expected value of x power 4. X power 4 is also a convex function, is greater than or equal to expected value of x power 4. So expected value of e to the power x is also a convex function, is also going to be greater than e to the power expected value of x. Okay. मैं इस expected value के साथ यहाँ पर ऐसे भी कर सकता था कि एक छोटा सा t लिख देता है, t is a constant, यहाँ t यहाँ पे भी आ जाता, it's a constant. तो यहाँ पे you can probably realize कि ये हमारे पास moment generating function है. Okay. So this is Jensen's inequality. I'm not going to talk more about it. Next, I'm going to move on another bound which is called Chernov's bound. Okay. This also gives you an estimate on probability. Now, this is the case when distribution may be known. Okay. Now you will say कि अगर आपको distribution known है तो आप तो exact answer निकाल लेंगे. फिर क्या जरूरत है Chernoff bound लगाने की? Well, there are situations when it is difficult to find the answer. When it is difficult to find the exact answer, distribution तो पता है, वो integrate ही नहीं होती हमसे. Distribution पता है वो integrate नहीं होती. So in that case, Chernoff bound can be very useful. And the Chernoff bound states that the probability that x is greater than equal to a is greater than equal to a is less than equal to e to the minus t times a m of t for all t. हर t के लिए, वो कौन सा t है ये आपने ढूंढना है, हर t के लिए ये satisfied है. For different t you will get different answers. जो आपको पसंद आए वो वाला रख लें, और पसंद कौन सा आएगा, जो सबसे शार्प सबसे टाइट होगा. ओके, सो m of t is nothing but the mgf. और mgf आपको तभी पता चलता है जब आपको डिस्ट्रीब्यूशन पता हो, because mgf and the distribution, the PMF or the PDF, they are 1:1. You can find one from the other. Okay. So I'll give you a very quick example. Okay, let's say you have a Poisson random variable with parameter lambda. Okay, and I'm interested in the probability x is greater than equal to I. Okay. X is greater than equal to I. So what is the exact answer? We know the exact answer. It's a Poisson distribution. X is greater than equal to I is equal to n going from I to infinity. Poisson distribution is e to the minus lambda power n over n factorial. Okay. This is very hard to compute. For example, if I is 150, then this will be very hard to compute. Okay. If I is close to zero, then it might be easier to compute by taking the complementary probability. Again, as such, जो है इसको करना बहुत मुश्किल है. So Chernoff bound can be used to answer this question. Okay. सबसे पहले तो हमें पता चलना चाहिए कि m of t क्या है इसमें. M of t. What is the moment generating function here? The moment generating function is expected value of e to the power t x, which is equal to I going from 0 to infinity e to the t I e to minus lambda power I over I factorial. With some manipulation, you can show that this is equal to, not too difficult, बहुत आसान है ये show करना, हम notes में show भी कर देंगे, ठीक है, is equal to this. This is moment generating function. Now the probability x is greater than equal to I, applying the Chernoff bound will be less than or equal to e to the power minus ti into m of t, which is e to the lambda e to t minus 1 for all t. हर t के लिए ये है. कौन सा t सिलेक्ट करें? t is equal to 0 सिलेक्ट करें, 1 सिलेक्ट करें, 3 सिलेक्ट करें, 2.5 सिलेक्ट करें, क्या वैल्यू ऑफ t हम सिलेक्ट करें? So this expression on the right, which is e to the lambda e power t minus 1 minus ti, ये आपके पास एक्सप्रेशन है, ठीक है. ये कब मिनिमाइज होगी? I want the bound to be sharper. Okay, we want the bound to be sharper or tight. Sharper या tight एक ही बात है, ठीक है. So I would like this quantity on the right, to be as small as possible. This happens when we have lambda e to the power t minus 1 minus ti is as small as possible. Okay. And now, since this Chernoff bound is true for all value of t, and we are free to choose t, ऐसा t choose करते हैं. Choose a t which minimizes above. ऐसा t choose करते हैं जो इसको मिनिमाइज कर देता है, ठीक है. कैसे करेंगे वो ये ऐसा t चूज करेंगे, और उसका डेरिवेटिव लें विद रिस्पेक्ट टू t, set it equal to 0, and we take the derivative with respect to t. This would be equal to lambda e to the t, so d by dt लेके सेट इक्वल टू 0, so lambda et minus I is equal to 0. This gives you lambda et is equal to I, or e power t is equal to I over lambda, or t is equal to log of I over lambda. Log is log of to the exponential, natural log. ठीक है. So t की ये वैल्यू पुट करेंगे, t की ये वैल्यू पुट करेंगे, तो this guy will be minimized, and when this guy is minimized, this guy will be minimized, this guy will be minimized. ठीक है. So that is the sharpest bound. Although it is true for any value of t, it is true for any value of t, but the sharpest one is this. अगर आपको मैं कहूं कि एक इवेंट है जिसकी प्रोबेबिलिटी लेस देन 0.64 है, और उसी इवेंट की आपको बताऊं प्रोबेबिलिटी लेस देन 0.32 है, तो कौन सा चूज करेंगे? वो ऑफ कोर्स 0.32 वाला चूज करेंगे. ठीक है. So there's one more example when you have a random variable which is normally distributed. उस पे भी चरना फॉर्म लगाते हैं, और वो चरना फॉर्म के साथ वो हम नोट्स के अंदर ऐड कर देंगे. प्लीज टेक अ लुक एट दैट एज वेल. आई एम गोइंग टू स्विच गियर्स अ लिटिल बिट नाउ. अभी थोड़ा गियर स्विच करते हैं एंड गो बैक टू another topic that we have seen before. तो पहले हम देख चुके हैं, and this topic is about सैम्पलिंग, या इसको कभी कभी कहते हैं सर्वे सैम्पलिंग. I'm going to go to the topic of survey sampling. We have already seen the definition of sample mean. कैसे होती है कि let x1, x2 all the way up to xn are samples from a large population. So let's say you have a very large population जिसमें लोगों की हाइट है, और ये आपने n लोगों को पिक किया और उनकी हाइट मेजर कर लिया. सो यू गॉट अ सैंपल. ये सैंपल आपका रैंडम सैंपल है. सो इफ यू पिक आउट ऑफ द 7 point something billion people in the world, if you pick 100 people और उन 100 लोगों की आप हाइट मेजर कर लें, उनका एवरेज ले लें, यू कैन सी कि जो एवरेज जो आपके पास आएगी वो डिपेंड करती है आपने सैंपल कैसा पिक किया था. हो सकता है कि कोई और सैंपल पिक करें तो कुछ और आपके पास एवरेज आ जाए. ठीक है. सो let's assume कि इस population की जो has parameters has mean mu and variance sigma square. इस population का mean mu है और variance उसका sigma square है. ठीक है. So that means कि xi also has mean mu and variance sigma square. Each of the sample that you will pick उसकी जो है मीन म्यू होगा और वेरिएंस उसकी सिग्मा स्क्वायर होगी. ठीक है. सो आई डिफाइन द सैंपल मीन एज द फॉलोइंग, and no surprises here. X bar is equal to 1 over n x1 plus x2 plus ... up to xn. ये हमारा सैंपल मीन है. Now what we had seen before, एक दफा हमने मेंशन किया था कि since this sample that you are picking, ये जो n लोग आपने पिक किए हैं, these are randomly selected people. किसी और को टास्क देंगे वो कोई और 100 लोग पिक कर लेगा, किसी और थर्ड पार्टी को देंगे तो वो एक और 100 पिक कर लेगा. सो since this is a random sample, ये आपने एक एक्सपेरिमेंट किया जिसमें ये 100 लोग आपके पास आ गए, जो आउटकम आपके पास आई है, that outcome will vary when you perform the experiment again. So that means कि x bar, which is the sample mean, normally तो हमें पता है कि mean value जो होती है, expected value is always a constant. But in this case for the survey sampling case, x bar is a random variable. Very, very important to realize that. X bar is a random variable. And we had actually computed the expected value of x bar as well. What is the expected value of x bar? Expected value of x bar, expectation is linear, so this would be equal to 1 over n expected value of x1 plus expected value of x2 plus so on plus expected value of xn. Okay. So this would be equal to 1 over n into हर एक की expected value जो है वो बराबर है, और वो कितनी है? mu. So n times mu, which is equal to mu. So ये हमारे पास आ गया expected value of x bar. x bar एक ऐसा रैंडम वेरिएबल है जिसकी एक्सपेक्टेड वैल्यू म्यू है. अब अगर कोई आपसे कहे, अगर आपसे कहे कि दुनिया के जितने लोग हैं उनकी हाइट, एवरेज हाइट आप मुझे बताएं, ठीक है. What you will do, the best you can do is pick a random sample, and from that random sample take the average of that. You will get x bar and you will get expected value of you will get x bar, and that x bar you can say कि यार ये represent करता है mu को, although you have not received the value of expected value of x bar, क्योंकि expected value of x bar लेने के लिए आपको x bar की हर वैल्यू का पता होना चाहिए, जो हमें नहीं पता होगा. हमने तो एक ही सैंपल लिया है, ठीक है. सो एक सैंपल लेने से उसकी एवरेज वैल्यू निकाली तो आपको एक्स बार का पता चला. You don't know about expected value of x bar, but we can still make an estimate. हम ये कह सकते हैं, since this is an estimate, we will say कि ये जो मेरे पास एक रैंडम सैंपल मैंने लिया था, एक दफा एक्सपेरिमेंट परफॉर्म किया था, यही रैंडम सैंपल था और यही मीन वैल्यू ले लेते हैं, ठीक है. एंड द रीजन फॉर दैट इज कि एक्सपेक्टेड वैल्यू ऑफ द x bar would be equal to mu. What is variance of, अगर x bar एक रैंडम वेरिएबल है, उसके मीन है तो उसकी वेरिएंस भी होगी. What is the variance of x bar? And the variance of x bar, we had also calculated this. These guys are independent identically distributed, IID. So the variance of x bar would be equal to the variance of 1 over n sigma I is equal to 1 to n xi. ठीक है, ये इसकी वेरिएंस हमने निकालनी है. और वेरिएंस ऑफ a टाइम्स, ये देखें, this guy here is a random variable, sum of many random variables is also a random variable. Okay? So this would be 1 over n square variance of summation of I is equal to 1 to n xi. Now जब हम correlation और variance covariance पढ़ रहे थे तो हमने देखा था वहां पे कि if these guys are independent, then the variance of the sum is equal to the sum of variances. So this would be equal to I is equal to 1 to n variance of xi, and the variance of xi is sigma square. So this would be equal to 1 over n square into n times sigma square, which is equal to sigma square over n. This is the variance of x bar. Okay. What this tells us कि expected value of x bar ये आपके पास mu आता है और variance of x bar ये आपके पास sigma square over n आता है. अच्छा, x bar, don't forget कि x bar is the mean of those n samples, ठीक है. What this tells us if you take more samples, which means कि larger n, if you take more samples, तो expected value of x bar पे कोई फर्क नहीं पड़ता. Expected value of x bar remains unaffected. No impact on the mean of the expected value, mean of the x bar. But it reduces the variance of x bar. उसका मतलब क्या है? उसका मतलब यह है कि जितना बड़ा सैंपल लेते जाएंगे, n बड़ा करते जाएंगे, वैसे वैसे x बार की वेरिएंस कम होती जाएगी. What this tells us is कि अगर मेरे पास एक लार्ज पॉपुलेशन है, उसमें से मैं एक छोटा सा सैंपल ले लूं तो उसकी कोई वेरिएंस होगी. Which means कि जब वेरिएंस ज्यादा होगी तो मुझे नहीं पता कि मैंने जो उसका आंसर दिया है x बार की को मैंने कहा था कि यार यही एक्सपेक्टेड वैल्यू ऑफ द पॉपुलेशन ले लो, इसी को मीन के लिए ले लो. अगर मैं आपसे ये कहूं कि n is infinite, if I tell you कि n is infinite, which means कि आपने दुनिया में जितने लोग हैं उन सब की हाइट मेजर कर ली है. जब आपने उन सब की हाइट मेजर कर ली है, उसका एवरेज लिया, तो आपको तो ट्रू हाइट पता चल गई है, आपको पॉपुलेशन की एवरेज पता चल गई है, ट्रू एवरेज हाइट आपको पता चल गई है. So that means you already found mu, which means कि अगर वेरिएंस हम कम करते जाएंगे, सैंपल साइज बढ़ा करते जाएंगे, वेरिएंस कम करते जाएंगे, वैसे वैसे x bar will accurately represent mu. So we will be able to use x bar in place of mu more accurately. So I'm also going to define, जो हमने पहले भी define किया हुआ है, by the way, we are also going to redefine s square defined as 1 over n minus 1 summation I is equal to 1 to n xi minus x bar whole square. This is similar to variance. कुछ थोड़ा सा इसमें इशू है, डिफरेंस है, वो 1 over n की बजाय 1 over n minus 1, and there is a reason for that. S square is, इस definition के पीछे एक reason है, is called sample variance, is called sample variance, इसको sample variance कहते हैं, ठीक है. With some effort we can show that, और ये हम नोट्स में आपके साथ शेयर भी करेंगे, that the expected value of s square is equal to sigma square, and that is why हमने यहाँ डेफिनेशन में इसके 1 over n minus 1 लिया था, 1 over n नहीं लिया था. अगर हम ये 1 over n लेते तो एक्सपेक्टेड वैल्यू ऑफ s स्क्वायर जो है वो सिग्मा स्क्वायर के बराबर ना आती, ठीक है. सो ये लेने से हमें क्या फायदा हुआ, ये लेने से हमें ये फायदा हुआ, अब हम ये कहते हैं कि एक्सपेक्टेड वैल्यू ऑफ x बार इज म्यू एंड एक्सपेक्टेड वैल्यू ऑफ ये क्वांटिटी जो हमने डिफाइन कर दी है s स्क्वायर इज इक्वल टू सिग्मा स्क्वायर. तो इफ यू हैव अ बिग पॉपुलेशन, you have a big population and you want to find the mean and the variance of that population, तो आपको शायद वो पता नहीं होगी, आपको वो शायद पता नहीं चल सकती, but if you take a sample, उसका सैंपल लें, उसमें से आपको x बार पता चल जाएगा. You can use x bar in place of mu. This would not be accurate, this would be an estimate, but we can still use it. जितना बड़ा सैंपल करते जाएंगे उतना ज्यादा इस यूजेज की एक्यूरेसी बढ़ती जाएगी, The larger the sample, the closer x bar will represent mu. Okay, and similarly you can use s square as an estimate of the population variance. Sigma square can be used as estimate of sigma square, and x bar can be used as estimate of mu. Okay, so x bar and s square are good representations of mu and sigma square respectively. Okay, so now I am going to talk about and we have already seen this, is called the weak law of large number. This is one of the two major results of probability theory, and the other one being the central limit theorem. वो इसी पेज पे दोनों कवर कर देंगे. So weak law of large number क्या कहता है? Weak law of large number कहता है कि let's say कि you have x1 x2 dot 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 up to xn, a sequence of IID, independent identically distributed random variables, each with mean mu and variance sigma square, Okay, and we have x bar, we know, is 1 over n summation I is equal to 1 to n xi. Okay, the weak law of large number says okay, for any epsilon greater than 0, you can pick epsilon to be as small as you want, as large as you want. For any epsilon greater than 0, weak law of large number says that the probability that x bar minus mu exceeds this guy epsilon, goes to zero as n going to infinity. पहले इस इक्वेशन को सिंक इन करें. ये क्या कह रही है? ये कह रही है कि the difference between x bar and mu, we know that the expected value of x bar ये mu होती है. So यहाँ पे हम कह रहे हैं कि एक रैंडम वेरिएबल है और वो रैंडम वेरिएबल उसमें उसके और उसके मीन के दरमियान जो डिफरेंस है in either direction, the difference between these two exceeds some epsilon. For any value of epsilon, it goes to 0. I can pick epsilon to be as small as possible. So essentially ये इक्वेशन मुझे क्या कह रही है? ये इक्वेशन मुझे कह रही है कि x bar और mu, they become extremely close to each other. as n increases, n infinity के लिए x bar और mu ये दोनों जो है extremely close हो जाएंगे. Why? Because this expression is true. This expression is true for every value of epsilon. I can pick epsilon to be 10 to the minus 99, 10 to the minus 100. कुछ भी पिक कर सकते हैं, बहुत छोटा पिक कर सकते हैं, ठीक है. And the proof of the weak law of large numbers is even simpler. We know that expected value of x bar is mu and variance of x bar अभी हमने ऊपर देखी is sigma square over n. Okay. Chebyshev inequality निकालते हैं इसके ऊपर. Chebyshev हमें क्या कहती है? Chebyshev inequality कहती है कि probability that x bar minus mu is greater than epsilon, this has to be less than equal to sigma square over, which is the variance of x bar divided by epsilon square. Okay, and we know that this goes to 0 as n goes to infinity. This goes to 0 as n goes to infinity. Hence proved. ये एक लाइन में प्रूव हो गया. Okay, there is, by the way, a strong law of large numbers as well. Strong law of large numbers as well, which is a stronger statement, obviously, as compared to the weak law of large numbers. And strong law of large numbers without proof, I will show, I will write that this says that limit n going to infinity, x bar is equal to mu. The probability of x bar equal to mu is equal to 1. So ये क्या कह रहा है आपके पास कि एक रैंडम वेरिएबल है आपके पास, एक रैंडम वेरिएबल है. If you have a very large number of observations, very large number of observations, तो उन सब का आप एवरेज ले लें, उन large number of observations का एवरेज ले लें, उन सैंपल्स का आप एवरेज ले लें, you will converge to the mean. That is why when you roll a dice, ठीक है, उसको 10 दफा, 20 दफा, 50 दफा उसको थ्रो कर देंगे, जो भी आपके पास नंबर्स आते हैं उनकी एवरेज अगर लेंगे, तो ट्रू एवरेज क्या होती है? 1 + 2 + 3 + 4 + 5 + 6 divided by 6, which is 3.5. सो अगर आप उसको इनफाइनाइट टाइम्स रोल करेंगे, जो भी आपके पास फेसेस आए हैं, उन सब को ऐड करें और उतनी उस बड़े नंबर से डिवाइड करें, यू विल एंड अप गेटिंग 3.5. कॉइन टॉस करते जाएं, 50% of the time you will see a tail, 50% of the time you will see a head. Okay? So random variables will converge to their mean, So this is the law of large numbers, strong law of large numbers and weak law of large numbers. ये दोनों हमने cover कर लिए. Now let's move to the other big results from the probability theory, which is central limit theorem. ये भी हमने पहले देखा है in some form. Central limit theorem. And the central limit theorem says, again, x1, x2, ... xn are IID, ठीक है, mean mu, variance sigma square, हर एक का mean mu है और variance sigma square है. Okay, then summation I is equal to 1 to n xi converges to normal with some mean and variance, ठीक है. क्या मीन होना चाहिए इसका? with mean, so हर एक का मीन ऐड कर देंगे, with mean n times mu and variance n times sigma square. So that is, ये convergence का मतलब है n going to infinity. That is, as n goes to infinity, the probability x1 plus x2 plus ... plus xn, which is this summation here, this guy converges to normal with mean and mu and variance and sigma square. So हम इसको जो है वो स्टैंडर्डाइज करते हैं. रिमेंबर हमारे पास जब एक नॉर्मल था, एक जेनेरिक नॉर्मल, उसको हम स्टैंडर्डाइज करते थे, मीन माइनस कर दें, स्टैंडर्ड डेविएशंस डिवाइड कर दें, यू विल गेट अ नॉर्मल 0 1. सो इसमें से इसका मीन माइनस कर देते हैं और इसकी स्टैंडर्ड डेविएशन से डिवाइड कर देते हैं, स्क्वायर रूट ऑफ n सिग्मा से डिवाइड कर देते हैं. सो द प्रोबेबिलिटी दिस इज लेस देन इक्वल टू सम z it converges to phi of z, which is the CDF of normal 0, 1. Standard normal का CDF है ये. Standard normal का CDF है. Equivalently, if x bar is equal to 1 over n summation I is equal to 1 to n xi, then we know that expected value of x bar, हम सबको पता है कि ये mu है, and variance of x bar is equal to sigma square over n. Okay? Then, as n going to infinity, ये x bar जो है, यहाँ पे तो ऊपर हमने कहा ना कि summation converges to normal. Summation converges to normal. तो x bar जो है वो भी तो summation ही है divided by n. अगर ये वाली चीज normal है तो उसको अगर हम n से divide कर दें तो भी normal ही रहेगी. Then as n goes to infinity, and as n goes to infinity, x bar converges to normal with mean, जो भी उसका mean है mu, and the variance sigma square over n. Or x bar minus mu divided by sigma square root of n, इधर आ जाएगा ऊपर. This is converges to approximately normal 0, 1. This is your central limit theorem. Okay. I'll give you a very, very quick example before we close off. So let's say xi are uniform 0, 1, IID. So मीन कितना है इसका? मीन है 0.5. 0 to 1 यूनिफॉर्म है, मीन है 0.5. ठीक है. If you take 60 of them, I is equal to 1 to 60 xi. ठीक है. तो उसका मीन क्या होगा? उसका मीन होगा 30. But I am interested in the probability that this guy is less than 35. Okay. So this guy, according to the central limit theorem, this guy converges to normal. This converges to normal with mean 60 into 1 over 2 and variance 60 into uniform 0, 1 hai, so b minus a whole square over 12, it's 1 over 12. So that is, this is normal with mean 30 and variance 5. Mean 30 and variance 5. So now to answer this probability question, this would be equal to the probability. इसमें से इसका mean minus करें, with standard deviation से divide करें, you will end up getting z, which is standard normal variable. So 35 minus 30 divided by square root of 5. Which is equal to phi of, by the way, z is normal, 0, 1. So this is equal to phi of square root of 5, which is equal to 0.9873. ये टेबल से देख सकते हैं. Okay. So there is a couple of more examples that we will provide in the notes, and next time we are going to cover the estimation of the parameters mu और sigma square. एक population है जिसके mean mu है और variance sigma square है. हम उनकी estimation next time cover करेंगे. And in addition to that, we will talk about how confident you are about your estimates. तो जो भी आपने estimates लगाए हैं एक population के parameters के बारे में, what is your confidence level? तो उनको हम confidence intervals बोलते हैं, and we will cover both of those in the next lecture. Yeah. So if there are any questions, I will be happy to answer. Otherwise, we will close the session. कोई question है? Anyone has a question? It looks like there are no questions. I'm going to stop the share and then I will close the session. Thank you.